Welcome everybody to the first of our CSE110 live sessions. I'm Ryan Muth.
And I'm Phil Miller.
And we're here to answer your questions. We've got a bunch of questions from the discussion boards that we're going to try and answer first. But we're also watching on the chat that is next to the display here. So if you have anything that you want to ask while we're here, just go ahead and drop something into that chat. We're watching it, and we'll try to answer those questions. Okay? So what do we have first?
The first question is, it's a multi-part question, but the first part of the question is, what's the best field of computer science for a female?
Ooh, that's a really good question. That's really hard for us to answer, both two being dudes, but my take on this is that computer science is for everybody, right? Computer science is a discipline that anybody can enjoy and anybody can succeed in. And what it comes down to is not like male or female, but whatever your interests are, right? If you're interested in medical field, if you're interested in finance, if you're interested in business, if you're interested in video game programming, anything like that, pursue that interest. There's a computer science discipline that follows that, and you'll be much happier following something that is your sort of passion rather than something that is what people tell you to do, right? So you should do what sounds fun rather than what people say you should do.
I agree. The second part of the question, I think you did a good job of answering both parts, but which field is the most rewarding in computer science? Possibly data science. And I think the answer is very similar, right? It's not going to be a one or two that are your top most rewarding fields in computer science. It's going to depend very much on individuals. Me personally, I like business application development, which sounds really boring to most people. But I find it fascinating. The reason I find it fascinating is because business application development, what we're doing is going into a business and finding ways to automate their processes and help them do what they do better so that they can compete against their competitors and do better in business. And the cool thing about business is every business, even two businesses that do the same thing, do them in two different ways because they're trying to compete against each other. So whenever you go into to help a business automate their processes, you're learning something new, not just about potentially a new business, but a new way that a business does this kind of thing. And so I always find it very rewarding, very challenging. And that's my kind of thing, but other people like game programming or, there's embedded systems programming.
Yeah, that's my bag. I really like to build things and then program them to run around in the world and stuff like that. That's a lot of fun for me. But some people hate it with a passion, right? And it's really about, what you are attracted to, and that's what's going to be the most rewarding for you.
Right, and that's one of the really cool things about computer science is it is so broadly applicable. We are leveraging computers and software in more and more areas in our life and in our world, and we're going to continue to do this. So, one thing, if you're really up for the cutting edge, is look for places where there aren't computers and software now and ask yourself, how can you apply computers and software to problems in that domain? Especially if that domain is also something that interests you. So,
yeah.
All right.
Our next question is, and this one is related, a couple of people have asked this already, is where do you think the industry for computer programming is heading? There are a lot of growth areas in programming. There is all of web app development is big and huge and growing. All the app development on phones, everything that you use on your phone, that is a massive place to work. A big area that is growing right now is in artificial intelligence and deep learning. That is the previous question referred to data science, and that's a big part of it. The sort of hiring titles that people are hiring for are called data scientists, and these are actually programming positions, but you're principally focused on how to make meaning out of a bunch of random data and measurements, right? So it's not really random, but it's measurements and information that they collect from all of the services that we use, like Facebook and Google and stuff like that. How do we make meaning out of that? How do we react to it? How do we make it what they call actionable? How do you make money off of it, basically, right? And how do you make people's lives better with that sort of thing? That's a huge growing area, and that takes a lot of statistics, and it takes a lot of programming skills. But it's like everybody's figuring out what it could be, and it's really exciting places for growth. What do you think?
I think it would be challenging to come up with areas in the industry that aren't experiencing growth.
Right.
That would be the challenging part.
Yeah.
Even technologies that are considered by many to be kind of old and antiquated, a lot of those are seeing revivals. So the whole idea, there's big iron mainframes. Some of that is seeing revival. So, there are parts of the industry, programmers that are programming in languages like COBOL, which is an ancient language, but the demand for these programmers is such that they make, several $100,000 a year. So,
Absolutely. Next is, do you think it's best to work for a company in a physical location, or do you like the normalization of working from home via the internet? I am really mixed on this, because right now, like my life is pretty much split between the two. I love having an office to come to. This is Phil's office, so he's got really nice whiteboard decorations and stuff like that. My office is full of toys and hardware and all kinds of stuff. I love having an office to come to and a place to work, and a space that's my own, right? That I own. But sometimes an office can be really distracting. Like, people will drop by and want to talk, and it's hard to stay on task. And I like working at home sometimes too, online, because I can just shut down all of my email and my chat and really focus on something. But sometimes I don't have the same resources as I do at a physical location. But it's entirely up to preference. A lot of people that have families love working at home because it allows them to have a more flexible schedule, and they can kind of do anything from anywhere, which has the opposite problem of sometimes that bleeds over into your life. Like, it's hard to say I'm not in the office anymore when your office is your home, and that can be very challenging for some people. So again, it's really up to what you prefer. These are all just sort of things you should think about if you're considering these different types of opportunities.
Yeah, the flexibility is the key part there, I think. And a lot of jobs in the industry do offer some degree of flexibility there. Most of my friends that are out in the industry programming split their time between working in the office and working at home.
Yeah.
Because they both of those formats have their advantages and disadvantages. When you're collaborating with someone, there's nothing better than being face to face.
Yeah.
But sometimes it's nice to have a nice quiet space where maybe the only thing that's going to interrupt you is your cat.
Will the majority of people continue to work for large companies like Microsoft and Google? Probably. I mean, that's a huge concentration of resources, and it's the internet is and its scale, and computers and their scale are kind of necessary for a lot of those large companies to work. That's not to say there aren't a lot of opportunities for small companies or individuals to do their own independent work. So again, it's like up to you where you want to go. But large companies have a lot of resources. Phil and I started working for a small university years ago, and when we moved to ASU, it was like mind-blowing, the amount of resources that were available and the opportunities that were available at a larger organization. And sure, there's extra bureaucracy and red tape and all kinds of stuff like that, but the benefits are amazing sometimes. So, but it's up to personal preference.
This next question, what do you think will be the best fields to go in for the longevity of computer programming career? Similar to a previous question. I'm thinking better than a field or a subfield to go into is an attitude has been since its inception, in a state of massive evolution and change, and that's not going to change anytime soon. There are 500 or so programming languages in fairly common use today. There'll be probably in the next 25 years 500 new programming languages in common use. Some languages will go out of favor. Some programming paradigms and tools will be developed and others will go out of favor. Old ones will come back again. And in order to stay relevant and in demand and useful and purposeful in the field, you have to be the kind of person that is always learning something new. You're always striving to do what you currently do and leverage the tools and technologies and languages that you're currently using to the best of your ability, but always trying to learn one or two things at the same time. And if you're aiming towards what's going to make you most marketable in the future, predicting the future is difficult. So my advice is the same advice we gave with some of this other stuff. Focus on the languages and the tools and the methodologies that you find interesting and personally enriching, and then look for opportunities to use those.
Yeah, they say the half-life of knowledge in this field is about 5 years. So after 5 years, half of what you know, if you're a professional in programming, half of what you know is no longer relevant, right? I don't think that's entirely true. I think there's a kernel of foundational knowledge that is super important. That's one of the things we want to teach in this class primarily, is the foundations of what computers are capable of, how they operate, and some problem solving skills. And if you nail these, then that opens a lot of doors to lots of other different kinds of knowledge, and it becomes way easier to teach yourself. So that's the sort of dovetail with what Phil was talking about, is keep growing, and you'll be able to sort of adapt as the industry changes, and it's going to change. That's just the nature of how all of this works.
Right. And your rate of growth, a lot of people focus on the rate of growth, like I'm not learning fast enough. That's less important than learning something.
Yeah.
You learn at your own pace, acquire new skills and new knowledge at your own pace, and as long as you're learning a little more each day than you knew the day before, you're going to be fine. Mm-hmm. So this is an extension of the previous question. What's our prediction for 15, 20, and 30 years out of new technologies to hit the market? Things like robots and machine learning, some of which we've already talked about.
Yeah.
So I'll take a stab at this, and it's going to be pretty broad. Machine learning or artificial intelligence is going to be huge. We're going to have more and more autonomous things acting in the physical environment around us, apparently with intelligence. Self-driving cars are an obvious example that we're starting to see right now. And another trend that I think we'll see is computers are going to be embedded into everything. There's going to be some sort of a progression there. They'll probably be embedded into things like ballpoint pens before they're embedded into coffee cups. But I think they will eventually be embedded into both.
Yeah.
And the question you ask, well, why would anybody want to do that? Well, if you go back to the 1980s and asked why would anybody want to do this, it seems far from obvious at the time. Like right now, you would like, well, for obvious reasons. But back then, none of these reasons were obvious.
Right.
I couldn't imagine needing something like this.
Yeah.
Yet here it is. Why? And the answer is because we can. Because we can build these things and find a use for them.
Yeah.
And we will be able to cheaply build computers into something like a ballpoint pen. And as long as we can find a use for it, I think we will.
Yeah. On the flip side, so Phil is actually referencing my field. I'm a computer engineer, so my field is embedded systems. It's computers in stuff that do one thing their entire life and they do it well. I see sort of the opposite that's a very much an idea of centralized computing or decentralized computing. So computing everywhere. I see the opposite, where we might have that have wireless connections to a big machine somewhere like Google, and it is doing a lot of the processing for it. So what happens on our smartphones now is the beginning of that, where some of the apps that Google runs, the voice processing and stuff like that, all of that gets shuttled up to the cloud. The cloud does the processing, and then it comes back down. But as the little radios that make that possible and the ubiquity of internet access becomes wider, we'll have a lot more of that sort of offloading the processing to a big service, and then the answer coming down when you don't have that capability locally. So they call it the fog, they call it the mist, they call it the cloud, they call it all kinds of weird acronyms around weather. But the basic idea is that computing is available at different levels anywhere on the planet, and you can have as much computing as you want any location on the planet, which is a really interesting thing, and that gets very complicated. But the big challenge with answering this question is I see it as the opposite of the question, like, would I have been able to predict what is happening today 15, 20, or 30 years ago, right? 15 years ago, it was 2003-ish. It was early 2003. The iPhone hasn't come out yet. Smartphones were not a thing, right? Wireless internet was really nice. I had it for the first time in my university, and it was amazing. I was in college at the time. I was a junior. I didn't have a laptop. I had a desktop computer. Everybody that I knew had a desktop computer. I had a couple people that knew a couple people that had laptops, and they were like really fancy. Like, it was insane that they had those. And like mobile computing as a basic thing was not possible. Like autonomous cars and robots and all the stuff that we're seeing become commonplace now was so far away. We didn't even think it might be possible 15 years ago, right? Much less 30 years ago. I can't imagine what's going to happen in 2048. I don't know what the world is going to look like there, and I don't think anybody can predict that. So it's about being adaptable and finding what's interesting. I think you'll be successful.
So the one thing we do agree on, though, is one way or another, more computing.
More computing, yeah.
Which, from the perspective of this course in computer science, means more software.
Yeah.
Because without software, without programming, these things are just dead bricks, lumps of glass and metal and trace elements. So.
Awesome.
And take all of those predictions with a grain of salt.
Absolutely. Do not actually listen to us.
Some questions specific to the course. What's the best book reference for this course? So some students like to augment this course. This course is designed and built to be self-sufficient. Everything you need for this course should be available through the edX platform. But some people like to go out and acquire some additional supportive materials like textbooks or books. I have a huge collection of programming books, and I'm a fan of many of them. But my best advice for students who are looking for a book to help support what they're learning in a class like this is go to a local library or a local bookstore. Just grab a stack of 5 or 10 or 15 books that look interesting on the subject. Sit down with a cup of coffee or tea and flip through them and find some books that have a style that feels easy for you to read and comprehend, and it makes sense, the organization of the materials, and just pick one or two of those. So a couple that I do like, there's this one here. It's Think Like a Programmer, which is not language specific, and it focuses on the problem solving aspects of computer programming and computer science. And then here's one that's Python specific, Think Python. It's an O'Reilly book, which I'm a big fan of a lot of stuff that they process. It's very professionally organized. And both of them help you focus on the thing that both Ryan and I think is one of the most important, if not the most important aspect of this course, which is the problem solving and the mindset that goes into it, rather than the mechanics of a particular programming language like Python or Java.
Mm-hmm. Absolutely. Awesome. The next few questions are a little specific. A student wants to know if he is ID verified. So if you have successfully completed the ID verification process, if you've paid your $49, then you are ID verified, right? That is all you need to know. The deadline option, the thing that shows up at the message that shows up next to the deadlines, that's for everybody. So it's not specifically to you. It's just that part. But you should be able to check your profile on edX and see if you are ID verified, successfully ID verified for this class. If that's not the case, then you can email GFA at edX.org, and we'll be able to help you get ID verified if you have any questions about that. And then the next one is midterm exam question samples. So we don't post any samples of the midterm exam. We do, however, have a study guide posted. So on the top of the class, there's a bar with a bunch of pages listed, like course and discussions and what else does it look like? Progress and syllabus and schedule, important deadlines, code playgrounds. There's midterm and final exam study guides. You can go there and see the topics that are going to be on the exam. The questions are mostly multiple choice. So there's a multiple choice part, and then there's a programming part. The multiple choice questions are going to be pretty straightforward. You just brush up on your fundamentals, think about what is going to be there. We'll get closer. As we get closer, we'll have a more specific discussion about things that are on the midterm and what you can do to study. But in the meantime, it's really just focusing on what topic is there to do that.
And we'll probably incorporate some review into one of these live sessions just before the midterm and just before the final exam as well.
Yeah.
And the last question we have is, are there any suggestions of other courses from this university? And this is for a student who's interested in pursuing a master's in computer science. And I think the question is probably specifically asking about availability on GFA or edX.
Yeah, so ASU doesn't yet have a second class in this sequence for programming, but on GFA, that is possibly in the works. We're not totally sure at this point. But we do have, ASU does have an ASU online program, and we have masters in computer science and technology online that you can go and check out at the ASU online website. They have all the programs that ASU offers, and you can check those out if you're interested. From other universities, it's really about what you might want to pursue, what kind of topics. If you successfully complete this class and are looking for more, classes you might look for are things that have stuff like data structures or algorithms in them, where it kind of takes you to the next level of, here's some common patterns for solving problems, not just how do we solve problems. Right. Yeah.
And that's all the questions that we had posted to the discussion.
Cool. So we have a few seconds delay in between the video feed that is happening here and what we see online in the chat room. So if you guys have any questions at all, just real quick, post them into the chat room. Answer those questions if anybody has any. Otherwise, we're gonna close it down. Cool. Waiting. We're super excited to be working with you guys this semester. This is the second run of this course. We hope we've worked out most of the bugs, and we're excited to see what you think of the class and how everything works through. Everybody's been doing real well with the introductions, and particularly the building learning community stuff. If you haven't checked that out, you should go and see what other people's experiences are, because it's really great to see what everybody's sharing there.
Love reading your discussion posts and participating in those with you.
Absolutely. Okay, it seems like we don't have any more questions, so we'll see you guys online.
See you in what, 2 weeks?
2 weeks. We'll be doing this again in 2 weeks.
Bye.